Welcome pre-cal students to class today on this Tuesday the 29th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's go ahead and get started here. Good to see you guys yesterday, and I hope that you're doing well on your tests so far. Let's see here. First of all, we will have a quiz on Saturday, so make sure that you're excuse me, sorry about that, ready for your quizzes. Study hard and make sure you're ready for those. Your tests are due by tomorrow, so please don't forget that. All tests are due by tomorrow, completely done, all questions asked, or you will lose bonus points, so keep that in mind. I'm sorry, guys, my voice is really raspy. And then stay on top of your integrity sheets. Stay on top of those, please. Make sure you're doing your integrity sheets, okay? Very, very important. Do your homework every day. All right, let's take our first look this year at logarithms. Now, Matthew, you had these last year in Algebra 2, so they will look a little familiar. Caleb, hopefully you did also, but if you did not, it's no big deal. We're going to start with the basics and work our way forward. Your heading today is Logarithms, Lesson 4.3, and the date today is the 29th. Now remember, I go fast. Pause the video if you need to. First off, what is a logarithm? Now there should be a question mark there. I'll have to fix that later. What is a logarithm? A logarithm is just another way to write an exponential expression. For example, we all know that 2 to the third power equals 8. 2 times 2 times 2 equals 8. This is called an exponential expression because you've written the 8 as an exponent, 2 to the third power. Now look over here. All that we've done is we've taken the 2, the 3, and the 8, and we've put them in different places over here, 2, 3, and 8, with the word log, which of course stands for logarithm. And that's it. Students, look at this. That's all you do. A logarithm is just simply taking an exponential expression and writing it with the word log. Now don't understand me, logarithms are extremely helpful, and we're going to use them to help us solve exponential equations. They're definitely helpful, but the understanding of what a logarithm is not that difficult, okay? That's all that a logarithm is. Now, having said that, let's jump right into converting logarithm, that should be logarithmic and exponential expressions back and forth. Here is the model or formula that you're going to need when you start converting these logarithms to exponentials or exponentials to logarithms. Here is the model. A to the c power equals b is the exact same thing as c equals log with base a of 8. And by the way, let's go over some little bit of terms here I think you should write down. Whatever you're taking the logarithm of, in this case we're taking the logarithm of b. B is called your argument, if you want to make note of that, okay? So whatever you're taking the logarithm of is called your argument, and obviously this little letter here is called your base. That's your base. And how would you read this whole expression? You would say the logarithm with base a of b. Let me say that again. The logarithm with base a of b. Now in this class we'll use some slang. We'll probably just say log base a of b. Log base a of b. But either way, that's how you say that. But do you not see what we're doing here, men? Look at this. All that you're doing is you're taking your a, the base of your exponent, and writing it over here as the base of the logarithm. Your exponent, whatever it happens to be, always goes all by itself right here. And then over here, your base to a certain power equals a number. In this case up here it was an 8. Whatever this number here is what you take the logarithm of. In other words, that's going to be your argument. This number here, or variable, whatever it might be, will always be your argument. Students, if you can go back and forth and move these letters or numbers around, you'll be totally fine. It's really, really, really not that difficult, okay? So with that in mind, let's go ahead and practice converting back and forth between logarithmic form and exponential form. Here we go. You can work ahead or you can watch me. That's up to you. Let's do these 6 problems very quickly. Okay? Now, first of all, this is an exponential form, so I would like to write this in logarithmic form. So here we go. Remember, whatever your base is, it stays the base of the logarithm, okay? And whatever is all by itself, in this case it's 16, that's what you take the logarithm of. And then your exponent, whatever your exponent is, always goes over here. Now I think in the model that I gave you, in the model I gave you, it was written like this: x equals log base 2 of 16. And you can see, students, it really doesn't matter which side you put the x on and which side you put the logarithm. It doesn't matter. But that's it. If you can learn how to move these variables and numbers around, you will find this very, very easy. To be honest with you, I'm not trying to put pressure on you, but it's really just memorization. Either you're going to do the work and memorize it, or you're not. Okay? And that's something you've got to decide. Okay? All right, let's continue on and take a look at the next problem. All right, here we go. And actually, I don't want to do what I just did. I want to keep these in case we look back at them later. So hold on one second, please. Thank you. All right, let's take a look at the next problem. Again, if you're working ahead, that's fine. These are not too difficult. All right, let's go ahead and let's write this in logarithmic form. Now remember, the base of your exponent is always the base of your logarithm. So the base of your exponent is 10, so it goes here. Okay. Whatever is all by itself is what you're taking the logarithm of. It's your argument. And then your exponent, in this case it's -3, is always by itself. There we go. Okay, not too difficult, and I think we're going to whip through these 6 pretty quick. All right, let's take a look at this one. Now, first of all, whatever the base of your exponent is, that's always going to be the base of your logarithm. Whatever is all by itself over here in your exponential expression, that will be your argument, or in other words, what you're taking the logarithm of. And then your exponent will always be by itself over here. There we go. You just took an exponential expression and you wrote it logarithmically. Now, let's go ahead and take some logarithms and let's write them exponentially, okay? Well, remember, the base of your logarithm is always the base of your exponent, okay? And whatever is standing alone right here is always your power. And then, of course, the argument, whatever you're taking the logarithm of, in this case is 32, that is all by itself over here. There we go. And you might say, well, Mr. Earhart, I don't need to memorize this. I knew where the 2 and the 5 and the 32 went because 2 to the 5th power is 32, and there's no other way to arrange these numbers so that you get an equal statement. Very good. You're exactly right. But the problem with that is what about when you get to this next problem that has all variables? Okay? Then you've got a little bit of a problem. So you've really got to know, you've got to memorize where these variables or numbers go. Now, the base of your logarithm will be the base of your exponent, always. Whatever is all by itself is going to be your exponent. We're just going backwards, guys. Everything is backwards from what we did over here. And then your argument always stands by itself. There we go. Just like that. So you took a logarithmic expression and you wrote it exponentially. All of these expressions are equal. I'm giving you equivalent exponential and logarithmic expressions. All right, here we go. Now let's see. The base of the log will be the base of your exponent. Whatever is all by itself in the logarithmic expression will be your exponent. And then the argument always stands by itself. And your argument is m. And there we go. Actually, something's not right here. This should be an x. Sorry about that. I knew we didn't have 2 m's. There we go. All right. Hopefully I've not made other mistakes like that. So men, what we just did, excuse me, what we just did is we took some expressions that were written exponentially like these, and we wrote them logarithmically, and then we took these expressions that were logarithms and we wrote them as exponentials. Okay, now let's go ahead and continue on. Lastly, let's solve, contain your excitement, drum roll please, let's solve some logarithms. All right, let's solve some of these. Here we go. All right, we have 6 of these. Now, let me help you. Let me teach you how to solve these. I guess I could have given you some steps, but it's really so basic, there's just no need to do that, okay? But if you want to write some steps down, then feel free to do that. I wasn't being lazy. I just don't think it's necessary. But if you want to write some steps down, the first thing you do when you're solving a logarithm, and by the way, we're going to learn how to solve these using calculators tomorrow. I believe it's tomorrow. If not tomorrow, the next couple of days. But today we're going to solve these without a calculator. So the first thing you do when you're solving this logarithm is you say, you know what, I don't know what it equals. And you admit that and you set it equal to x. So basically what you're saying is this expression here equals what? I don't know, so I'm going to say it equals x. Fair enough, okay? And then step 2, look what we've done. Now that we have a logarithmic expression with an equal sign, can we not write this exponentially? Sure we can. We can write this exponentially. So the base of your log stays the base of your exponent. Whatever is all by itself over here becomes your power, and your argument is written all by itself. Now you see why we just practiced doing this, okay? So if you want some steps, I guess I could have typed them up for you. Step 1, you write the exponential expression equal to x, and then step 2, write the expression exponentially. And now look, guys, you've got to be creative. How's that? How is that for step 3? Be creative. Or here's step 3. Think, okay? I mean, look, you've got a base of 10 over here. I wish I had a base of 10 over here. If I did, then I would know what x is right away. Well, hold it. I can write this with a base of 10. Come on, guys. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So I can make a substitution. Look what I can do. 10,000 is the same thing as 10 to the 4th power. Isn't that easy? And now look, what does x have to be? I mean, you've got a base of 10 here, you've got a base of 10 here, both sides are equal, so what would you have to put in for x so that you get a true statement? Well, x has to be 4. This has to be a 4 right here. 10 to the 4th power equals 10 to the 4th power. So your answer is 4. X equals 4. So do you see what the key is? Please listen to me, men. It's easy to write the expression equal to x. That's easy. It's easy to write the expression exponentially. That's easy. What becomes difficult is writing both sides so that they have a base of 10, or excuse me, so that they have the same base. In this case, I had a base of 10 right here, so I knew I wanted this side over here to have a base of 10. Sometimes, men, you'll have to change both sides, okay? So this will be interesting, all right? Let's go ahead and try the next problem. You can work ahead or watch me, totally up to you. Okay, the first thing we do is we set it equal to x. The next thing we do is we write it exponentially. So I'm going to have 10 to the x power equals 0.01. Now I'm going to be honest with you. This one's not going to be very easy, okay? We're going to have to really, really think. Now maybe for you it is, and that's fine. For me, I'm just kind of thinking this isn't going to be too easy. So the first thing I'm going to do is I'm going to write my right side as a fraction. I think that's a good idea. So 0.01, and remember, I can't really give you steps on this. It's just being creative. You say, well, Mr. Earhart, why would you write it as a fraction? Guys, look, I knew if I wrote this as a fraction, I would have a denominator of 100. And isn't 100 a lot easier to write as a base of 10? I mean, at least I'm moving in the right direction. I'm still not done, but I'm getting there. So now I've taken 0.01 and I've written it as a fraction. Remember, 0.01 is 1/100th, okay? Now, this 100 in the denominator right here, could I not make this 100 right here become 10 squared? Sure I could. 10 times 10 is 100. Well, we're getting somewhere. Let's write up here what we have. We have 10 to the x equals 1 over 10 squared. We're getting somewhere. Now, hold it. I just had a thought, and I don't have many of those. If I take this 10 to the squared and I bring it up top, you should know by now how to do that, guys. We've talked about negative exponents before. You would get 10 to the what? Negative 2. Well, Mr. Earhart, what happened to the 1 that was up here? Well, okay, if you want to put times 1, that's fine, but times 1 is, anything times 1 is just itself. So I bring the 10 up top. Hey, notice the 10 doesn't change, just the exponent, okay? So I bring the 10 up top, and now my 2 becomes a negative 2. And now look, I've got a base of 10, I've got a base of 10, so what does x have to equal? X equals negative 2. These are a lot of fun, and students in the past have really liked these. You just got to be creative and think, all right? Okay, let's try this one here. Here we go. Let's go ahead and set it equal to x. And then we're going to write 2 to the x power equals 8. Well, guys, you should see this right away. I mean, we can write 8 with a power of 2. 2 times 2 is 4 times 2 is 8. So instead of writing an 8, I'm going to write 2 to the third power. There we go. Now you might be saying, Mr. Earhart, all of these problems work out so nice and pretty and there's no problems with writing them with like bases and all of that. You're right. You're right. But, and by the way, I just noticed something that's kind of funny. This 9 right here should be the base down here. That's kind of funny. And this 6 here should be a base. There we go. All right. You're right, and they're written that way on purpose. And there are some later we're going to do that don't work out all nice and pretty, and I'll teach you how to solve those then. But that won't be today, okay? All right, we have a base of 2, a base of 2. So what does x have to 3? What does x have to be? Well, it looks like x has to be 3 to me. X equals 3, okay? So with that in mind, let's continue on. And let's go on to this next problem that I typed incorrectly. All right, log base 9 of 3 equals x. Now let's write that exponentially. 9 to the x power equals 3. Ooh, this is not going to be pretty. How can I make a 3 become a 9? Well, maybe I shouldn't. Maybe I shouldn't do that. Maybe I should make the 9 become a 3. For the 9, how about if I put this? How about if I put 3 squared for the 9, and I've still got my x here on the outside? That's okay, isn't it? I just made a substitution. For 9, I put 3 squared, and that's totally legal. Okay? Now, you learned this before. You guys know that when you have a power raised to a power, you multiply them. So now I have 3 to the 2x equals 3. 3 to the 2x equals 3. Now this one, yes, students, you have like bases. That's true. That's true. A 3 and a 3. But this one's not going to be super easy to do in your head. Now maybe some of you guys can and maybe some of you can't, but there's a 1 here. So maybe you are good enough in math to look at this x and so say, okay, I've got a 3 here and a 3 here. I want this whole exponent here to be a 1. So what would x have to be to make this whole thing 1? Maybe some of you can see that it's 1/2 because 2 times 1/2 is 1. And that's good if you can. But Matthew or Caleb, if you're not really good at seeing stuff like that, then remember this. Whenever your bases are equal and you have something like an x and a 1, that's easy. X equals 1. But whenever it's a little more complex, and like this here, we have a base of 3 and a base of 3. Whenever your bases are the same and the exponents are a little confusing, feel free to do this if you want. You can just cross off your bases and write 2x equals 1, because really 2x should equal 1. If the bases are the same, then your exponent should also be the same, because both sides are supposed to be equal right here. So now divide both sides by 2 over here, and you will see x equals 1/2. There we go. Moving on. These are a lot of fun. It's kind of like a puzzle you have to solve, okay? And I hope you like puzzles. If you don't, then I guess you won't enjoy these as much as I do. But I like all math. So log base 6 of 1 equals x. This is going to be really interesting. Now, 6 to the x power equals 1. Now, watch this. You're saying, Mr. Earhart, there is no way I can write 1 as a power with a base of 6 or 6 with a base of 1. And I would say you're right. So now we have to think outside the box and say to ourselves, okay, self, I want this entire side here to equal what? 1. 6 to the x power equals 1. Now, what would I put for x? 6 to what power equals 1? Well, 6 to the 1 power is 6. 6 to the second power is 36. 6 to the third power is what? 216, I believe. None of those are working, but hold it. Mr. Earhart taught me that anything to the 0 power is 1. So if I have a 0 here, then 6 to the 0 power equals 1. So it only makes sense to me that x has to equal 0. And can I show you a little shortcut here that will help you guys? This is something you're going to learn later, so we'll go over this again later. But whenever you have a logarithm in the original problem and your argument is 1, okay, let me go ahead and get rid of that 1. Let's say the problem is written just like this. There. If you're ever given a logarithm, log base 6 of 1, anytime that your argument is 1, I don't care what the logarithm is or what the base is, it doesn't matter. Anytime your argument is 1, the entire log will always equal 0, just like this. All right? So there we go. So we're solving logarithmic expressions, okay? Last one, okay? So I know you're happy about that. Here we go. This will be pretty easy. Log base 8 of 8 equals, we don't know, so we're going to say x. And now we're going to write it exponentially. 8 to the x power, oh my goodness, look at this, equals 8. Well, talk about easy. Base matches base, so your power is 1 here, so x has to equal 1. So there, we solved the logarithm. The logarithm equals 1. Now, can I show you something? We're going to go over this later, but I'll go ahead and show you a little secret right now. Anytime you have a logarithm, like this one here, take a look at this. And whenever your base is identical to your argument, they have to be identical, the answer will always be 1. Always. I don't care if you're given a really difficult logarithm like this. Log base x plus 5 of x plus 5. If your base matches your argument identically, you know right away the entire logarithm always equals 1. You're finished. And remember what I taught you over here. Log base 6 of 1. Anytime your argument is 1, then the whole logarithm will always equal 0. That's the last problem we did, okay, the one before this one. All right, I hope this has been a help to you. I hope that you're getting all of this. Call or email if you have any questions. Here's your homework. I know it looks like a lot, but these are really quick, like the ones we did back here where you're just converting logarithmic to exponential and exponential to logarithmic. They're really, really fast. So the homework is not as bad as it looks. Page 387, 9 through 51 odd. Please get started now. Call or email if you have any questions. Hope you guys have a great day today. Finish up your tests and keep working hard.